Good morning, students. Today we'll discuss short answer question from gravitation. Yesterday I finished few SAQs from work, laws of motion. Then after continuation, gravitation. We are going according to important questions. From gravitation, you can get 1 4-mark question out of 4. So gravitation 4 marks weightage. In this one, orbital velocity. Define orbital velocity. So define orbital velocity. Derive the expression for orbital velocity. Recent annual examination question this one. Total 4 SAQs present in gravitation lesson. Orbital velocity, escape velocity, geostationary satellite, and last one is the Kepler laws of planetary motion. Out of these 4, you can get 1 SAQ in upcoming supplementary exam. First, orbital velocity. Derivation with definition. First definition, what is the meaning of orbital velocity? With derivation part. Orbital velocity means, for example, you take this is Earth. This is satellite. Every satellite revolving around the Earth. Every satellite revolving around the Earth in circular orbit. Minimum velocity. Every definition, orbital velocity and escape velocity starts from minimum. Minimum velocity required for a satellite. Minimum velocity required for an object to revolve around the Earth, to revolve around the gravitational field. That is orbital velocity. Orbital velocity means one object revolving, one object moving in circular orbit around the gravitational body. That is orbital velocity. You write statement in single line. Minimum velocity required for a satellite. Minimum velocity required for an object to revolve around the Earth. That is orbital velocity. Now, derivation part. First definition. Definition of orbital velocity. Upcoming there, escape velocity. Then after Kepler laws. And last one is the geostationary satellite. From this 4, you can get 1. All this one 3-star SAQ student. So definition, orbital velocity. Minimum velocity required for an object to revolve around the Earth. Nothing but gravitational field. This is the definition of orbital velocity. One object revolving around the gravitational body. One object revolving around the earth. That minimum velocity only orbital velocity. Now, this is the diagram. R is the radius of earth from earth surface, small h height. One object revolving in circular orbit. R is the radius of the earth. And what is the mass of the object? M. Capital M is the mass of the earth. Object revolving in circular orbit with how much speed or velocity? VO. One particle moving in circular path means two types of forces arises. Gravitational force provides centripetal force. If you remember writing gravitational force balances with centripetal force, that word wrong. Gravitational force provides centripetal force. In equilibrium, we are taking both are equal. So, one object revolving in circular orbit means gravitational force provides necessary centripetal force. So, centripetal force, you are reading in lower class, centripetal force, centrifugal force. Centripetal force means force acting toward the center. Centrifugal force means force away from the center, that is the lower class. Here, one object revolving in circular orbit means gravitational force provides centripetal force. What is the gravitational force? Newton law of gravitation means G m1 m2 by r square. This is F. Depend on this one, we are writing G. G stands for gravitational constant. M is the mass of one object. One more M, m1, m2. Two object, two different mass by r square. Nothing but distance, height square. Already R. One more H. From center of the earth to satellite. From center of the earth to object. What the height means? R plus H. So we are writing R plus H whole square. Gravitational force equals to centripetal force of the body. M V square by R. What is the centripetal force? Ordinary formula means M V square by R. M mass of the object. V velocity of object. R nothing but height or distance. Small m cancel. R plus H cancel. Then remaining steps. M cancel each other. Remaining step G m by R plus H. Capital G means gravitational constant. M mass of the earth. R plus H distance or height of the satellite from the center of earth. Right side V O square. Nothing but O stands for orbital velocity. V O square equals to Gm by R plus H. Remaining terms I'm writing Gm by R plus H, left side term, VO square, right side term, LHS, RHS, both are equal. That's why I'm writing like this. VO square equals to Gm by R, because here we are neglecting small h. What the reason means? If R very greater than H, capital R nothing but radius of the earth 6,400 kilometer. Compare with that 6,400 kilometer radius, height of the satellite neglect 36,000, 36 kilometer, 40 kilometer, 50 kilometer like that. That's why capital R is very big value. Compare with small h. On this condition, we are neglecting small h. VO equals to Gm by R under root. This is one equation, orbital velocity. One more, small g equals to Gm by R square. Relation in between small g, capital G, Gm by R square. This is the other SAQ student. relation in between small g and capital E, gm by r square. From this one, we are writing r square meaning r into r, gm by r, like this. R coming right side means r into r square. Gm by r equals to gr. That's why we are writing VO equals to under root of gr. This is our main equation for orbital velocity. Now listen, student. First orbital velocity. Minimum velocity required for an object. Minimum velocity required for a satellite to revolve around the earth, to revolve around the gravitational field. When a body moving in circular path, gravitational force, according to our situation, huge bodies present, big bodies present means gravitational force arises. Gravitational force provides a necessary centripetal force. Gravitational force gmm by r square, centripetal force mv square by r. M r plus h, m r plus h cancel each other. Remaining terms we wrote VO square equals to gm by r plus h. R very greater than small h. That's why we are writing h, neglect remaining term r. Gm by r nothing but gr. VO orbital velocity VO equals to under root of gr. This is the expression for orbital velocity. Now I am giving in 4 steps. This total orbital velocity you are writing in 4 steps, student. This one recent question from annual examination. So orbital velocity. Now listen, 4 steps. First definition. Previous, present, both are same explanation, but this is the short method. How to get answer in short way, in brief. So first 4 steps only, student. 4 marks question, number of times I am saying. 4 marks question means 4 scheme of evolution point. In this one, first statement, what is the definition of orbital velocity? So orbital velocity VO, minimum velocity required for an object, minimum velocity required for a satellite to revolve around the earth in circular orbit. So orbital velocity definition. Minimum velocity required for an object to revolve around the earth in circular orbit. Circular orbit. If you remember, they are writing definition like this, but that definition, this one very simple. What the definition means? See, this is the satellite. Minimum horizontal velocity. If you remember, going horizontal word. So minimum horizontal velocity required for a satellite to revolve around the earth, to revolve around the gravitational field in circular orbit. This definition, that definition, almost same meaning. An object in circular path. What is the minimum velocity? Minimum velocity required for an object to revolve around the earth in circular orbit. Then point number 1, they're watching statement, definition of orbital velocity in equilibrium position. Gravitational force provides centripetal force. So gravitational force gmm by r plus h whole square equals to centripetal force mv square by r. R plus h, m cancel each other. VO square equals to gm by r in bracket. If r very greater than h, obviously h value neglect. VO equals to gm by r. Now one more, small g equals to gm by r square. From this, step we are writing VO equals to GR. This answer, previous answer, 100% same. 4 schema of evolution point. First statement over 1 mark. In equilibrium position, gravitational force provides centripetal force. Point number 2. Then after substitution, there student, this equation. Point number 3, 3 marks up to here. 4 mark VO is equal to GR. Compulsory in bracket, you write this step. This is orbital velocity in short way. Definition. What is orbital velocity? Derive the expression for orbital velocity. From gravitation, you are reading 4. From that 4, you can get 1. Orbital velocity in recent exam came, annual examination. Sometimes repeated question coming student, answer easy. That's why I gave this orbital velocity explanation. Upcoming is their escape velocity. First orbital velocity, 4 steps. Like that same escape velocity also. See. This day, second question. Escape velocity. Define escape velocity. Derive the expression for escape velocity. This is the second SAQ from gravitation lesson. Escape velocity. You know, yesterday, recent ISRO launched one satellite student. Satellite launching vehicle, nothing but rockets, PSLV. In our India, we are calling that PSLV. Polar Satellite Launching Vehicle. You don't write that topic here. Just example I am giving. This is one rocket. One rocket moving upwards like this. Don't think Diwali rockets. This is main rocket. What ISRO, what NASA sending that rockets. So minimum velocity. I said previous definition also, minimum velocity. Minimum velocity required for an object to escape from ground, to escape from earth, to escape from gravitational field. This is vertical velocity. Previous case means horizontal velocity. Now present vertical velocity. Just you are writing simple words. Minimum velocity required for an object to escape from ground, to escape from earth, to escape from gravitational field. That is escape velocity. Now statement. Minimum velocity required for an object to escape from ground. Ground, nothing but earth only student. One body like this, see diagram. R is the radius of the earth. M is the mass of body, nothing but earth mass. One small m body moving upwards with how much? V velocity. So in equilibrium position, again two energies coming. One is the kinetic energy. In previous force case came student equilibrium. Now kinetic energy balances with gravitational potential energy. Gravitational potential energy. So in equilibrium position, gravitational potential energy balances with kinetic energy. This one we are writing law of conservation of energy. Sum of kinetic energy plus potential energy is equals to constant. Here we are writing kinetic energy plus potential energy is equal to 0. That gravitational potential energy plus kinetic energy overall 0. Going right side means GP is equals to minus K. Meaning kinetic energy equals to gravitational potential energy. This is the energy concept. Previous force concept. Gravitational force provides necessary centripetal force. Previous case. You know very well about kinetic energy. Half m v square. E stands for escape velocity. Equals to, what is the gravitational potential energy formula? Gmm by R. Formula only minus, work done against. That's why minus coming formula. Gmm by r, this one minus formula. Here minus means gravitational potential energy, nothing but gravitational pull downwards, body moving upwards. That's why it took minus. Minus of minus plus. You write half mv square equals to gmm by r. M cancel. These two going right. VE equals to 2gm by r, because VE square equals to 2 going right side means 2gm by r. This one escape velocity, student. After that, same like previous model only, small g equals to gm by r square. This word we are writing gr equals to gm by r. Everywhere you write what is the gm by r, what is the capital G in terms of small g. So gm by r equals to gr. This equation only under root of 2gr. This is escape velocity. So students, one is orbital velocity, one is escape velocity. From this two, 90% coming from this two, one. This two not there means more two. One is the geostationary satellite, next one is the Kepler laws. This question I am giving again in 4 steps, student. First statement, statement of escape velocity. Escape velocity statement. Minimum velocity required for an object to escape from ground gravitational pull earth. Then after kinetic energy equals to gravitational potential energy. Kinetic energy half mv square. Gravitational potential energy gmm by r. M cancel. V square equals to 2gm by r. V equals to 2gm by r under root. You know very well about gm by r equals to gr. Substitute here. In this one, 4 steps. Previous answer, present answer, 100% same. Diagram, no mark for diagrams. That's why I didn't draw any diagram. Previous diagrammatical explanation we are going. You are drawing diagram or you are not drawing diagram, nothing will happen. First statement, minimum velocity required for an object to escape from ground. Then after, in equilibrium position, kinetic energy balances with gravitational potential energy. Here, minus of minus, direct I wrote plus half mv square equals to gmm by r. M cancel. V equals to under root of 2gm by r. Square going right side, root. So V equals to under root of 2gm by r. Gr is equals to small g, capital R equals to gm by r. This value substitute here. You can get VE equals to under root of 2gr. This is the derivation part for escape velocity. So, 2 SAQs over, student. One is orbital velocity. Both answer looking like same. Same answer. Anyone getting confused means first practice derivation part. Then after write statement. Derivation part here, previous case, gravitational force equals to centripetal force. Force related concept, orbital velocity. Energy related concept, escape velocity. From this two, one coming, more two question there in this one. That one very easy. Geostationary satellite, its uses. What is the geostationary satellite means here? First statement. This is the question number 3. Geostationary satellite, its uses. Geo, anywhere geo word coming, earth. Geo, nothing but earth. Don't think geo sim. Geo, nothing but earth. Geostationary satellite. Geology. You want to study about earth. In intermediate secondary, geomagnetism, terrestrial magnetism. Anywhere geo word coming means earth. Geostationary satellite. For example, earth. You take earth, one satellite revolving like this. It finished one complete rotation, one complete circular rotation, oscillation, or circular orbit means what is the time taken by the satellite means 24 hours you take. 24 hours required for satellite to complete one circular orbit. One complete circular path means one complete track, circular track, it takes 24 hours. You know what is the rotation period, rotational period, nothing but in our daily life, 1 day, 24 hours. Rotation period of Earth, don't say revolution. Again, revolution period means year going. Just rotation period of Earth and revolution period of satellite, both are equal. That satellite we are calling geostationary satellite. Definition very simple. Revolution period of a satellite is equals to rotation period of Earth. This is revolution. This is self-rotation. Revolution time period of satellite equals to rotation period of Earth. That is called geostationary satellite. So we are writing statement definition. Revolution time period of a satellite is equals to rotational period or rotational time period of Earth. That is geostationary satellite. Next point, its time period. It's a time period 24 hours. Relative velocity with respect to Earth. Meaning relative velocity of satellite. Better you go. Relative velocity of geostationary satellite with respect to Earth is 0. What is the meaning for this one? First of all, geostationary satellite. Geo nothing but Earth. One satellite revolution. One satellite, for example, Earth rotating like this. Satellite also rotating. Earth rotating in 3 minutes. Satellite also rotating 3 minutes. Earth takes 24 hours for one complete self-rotation. Satellite takes one complete circular path, 24 hours. That type of satellite we are calling geostationary satellite. According to our physics definition, revolution time period of satellite equals to Rotational time period of Earth. Time period, nothing but 1 day. What is the time period of Earth means? 24 hours. Relative velocity. Relative velocity means, student, difference in between Earth and satellite velocity difference. Relative velocity of geostationary satellite with respect to Earth is 0 because both are moving at the same time. That's why I wrote uses. You write any two uses enough. For example, now you are listening class. I'm teaching this one total through communication system satellites. That is nothing but used in communication system, used in GPS, in internet GPS map. We are finding where is the location. All this one nothing but satellites only. So used in GPS, nothing but communication system. To study layers on and in the surface of Earth. Meaning, student, for example, few countries inside petroleum is there, few countries gold mines is there, few countries coal mines. We want study about this total studies compulsory satellite. Meaning, we want to study inside and outside of the earth layers. We want to study about weather report, means radars. Every radar working under satellites only. We want to estimate what is the size, shape of earth. We are using these satellites in wars. So in internet, we are using satellite. Number of users, student, you write any two. First of all, revolution time period equals to rotational time period of earth. Definition. Then after its time period is 24 hours. Relative velocity with respect to Earth is 0. Used in internet GPS system, student. We want to study layers on and inside the surface of the Earth. Okay. This is geostationary satellite. Okay, student. This is the question number 3. Today I finished up to now 3 SAQ, student. One is orbital velocity. Recent question, this one. Definition with centripetal force and gravitational force both are equating, we can get our answer. Second one is there escape velocity. This one new question. Definition, kinetic energy balances with gravitational potential energy with the derivation part. One more theoretical question. Geostationary satellite, the diagram not there, just definition, 1 or 2 points about geostationary satellite. Any two uses 1, 1, 2. Total you can get 4 marks. Geostationary satellite. Total 4 points from geostationary satellite. So one more question present from this gravitation, that is Kepler laws of planetary motion. Now here fourth question coming live. And now last question here, student, from this gravitation lesson. You are reading 4 SAQs. One is escape velocity. Second one, orbital velocity. Next, geostationary satellite. Last one is Kepler laws of planetary motion. From this 400%, you are getting one question. Kepler laws of planetary motion. This is the last SAQ. Oral gravitation lesson SAQ. One SAQ coming from gravitation. Don't read VSAQs. Don't read LAQ. Only 1 4 marks from gravitation lesson. Kepler laws of planetary motion. You know, every planet in our solar system, every planet revolving, every planet revolving around the sun. So Kepler scientists suggested three laws on planetary motion. Every planet revolving around the sun. It follows three different rules, different laws. That one only Kepler laws of planetary motion. So John Kepler suggested three laws of planetary motion. One is the first law we are calling law of orbit. Law of orbit. Next one, law of period. Otherwise means first one is the law of orbit orderwise. Next one is the law of area. Third one, law of period, time period. First law of orbit. See. Sun. Planet. So every planet, every statement with one statement student, one diagram present. What is the Kepler law of planetary motion? Law of orbit means every planet revolving around the sun in elliptical orbit, ellipse. You are reading this word in chemistry. Sommerfeld atomic model. Every electron revolving around the nucleus in elliptical orbit, ellipse. Just like every planet revolving around the sun in ellipse. That is only law of orbit. Every planet revolving around the sun in elliptical orbit. Here sun for one location, for sun 10 minutes. Okay. Okay. Students, this one will continue tomorrow because only 5 minutes. We are ready for one mathematics class now. Overall today, 1, 2, 3. One is the escape velocity. Next one is the orbital velocity. Next, geostationary satellite. One more balance question. Kepler laws of planetary motion. We'll discuss this answer tomorrow. Overall, from this 4 SAQ, you can get one. Kepler laws of planetary motion will continue in our next class. Okay. मौज के वो कहाँ है और रेगुलर आता है तो दिया है